All right, let's dive right in. This is a high-stakes mystery that pretty much every developer faces when they first step into cloud-native environments. You type your kubectl apply command and boom, seconds later, your database is up and running. It honestly feels like magic. But then, that nagging thought creeps into the back of your mind. Wait, where exactly is that data being written? If I delete this pod, is my data just gone forever? If the whole server crashes, does everything disappear? Well, today, we are going to answer those exact questions by tracing the journey of your data. Welcome to today's Explainer. We're taking a deep dive into how enterprise databases actually secure your data on the back end. We're going to strip away the magic and look at the actual nuts and bolts of Kubernetes, CSI, MariaDB, and Ceph. As you'll see, the cloud goes from being this mysterious black box to a highly logical, completely understandable machine. So here is our flight path for today. First, we'll unpack the Kubernetes storage mystery. Second, we'll look at CSI as the universal translator. Third, we'll trace a single SQL query. Fourth, we'll see how to survive a system crash. And finally, we'll wrap up with the enterprise data platform. Okay, section 1, the Kubernetes storage mystery. Let's look at what happens right after you deploy a database. We all know Kubernetes is this absolute powerhouse, right? It's an orchestrator that spins up pods, routes services, and manages your networks. But I want you to look really closely at that final bullet point. Kubernetes does not manage storage devices directly. Actually, scratch that. It refuses to, and there's a good reason for it. If Kubernetes had to understand the proprietary language of every single storage vendor out there, every cloud disk, every SAN, every single NAS, it would be literally impossible to maintain. So it completely relies on external systems to manage the actual physical disks. Which brings us to section 2, CSI, the universal translator. If Kubernetes won't talk to storage drives, how on earth does your database get saved? Well, because there was no single unified way to do this out of the box, the industry came together and created the Container Storage Interface, or CSI. You can think of CSI as this ultimate universal translator between Kubernetes and your storage. When Kubernetes needs space, it doesn't care what kind of hardware is sitting down in the basement. It just shouts, "Hey, I need a 100 gigabyte volume." The CSI driver hears that request, and it seamlessly translates it into the specific proprietary language of your storage backend, whether that's Ceph, a cloud disk, or a traditional SAN. But we've got to be really precise here. Take a look at those specific tasks. CSI is all about managing the lifecycle of the volume. It handles the creation, the mounting, expanding, and unmounting. But check out that crucial note at the bottom. CSI does not save the data itself. It's essentially just a traffic cop routing the requests. The actual permanent home for your bytes is the underlying storage system. Let's actually look at how this plays out in the real world. When you deploy a MariaDB instance for the very first time, this exact sequence kicks off. First, the new pod wakes up and realizes, hey, I need a persistent volume claim, or PVC. Second, that PVC asks the system's storage class to allocate the space. Third, the storage class dials up our translator, the CSI driver. And finally, the CSI driver commands the backend, in this case Ceph, to create a brand new volume. That volume then gets mounted directly into the pod. And why does this matter to you? Because to MariaDB, this whole complex dance is completely invisible. It just thinks it's writing to a perfectly normal Linux file system. Moving right along to section 3, tracing a SQL query. We've got the storage pipeline secured, so what happens to your actual data? Imagine a user clicks submit on your website. Millisecond 1, your application fires off an insert into user's SQL command. Millisecond 2, MariaDB grabs it, processes it into its buffer pool and redo log to make sure the transaction is safe. Millisecond 3, MariaDB flushes this down to what it assumes is just standard Linux file system storage. Millisecond 4, that data passes right through the CSI volume layer. Millisecond 5, bam! It physically hits the spinning disks or SSDs managed by Ceph. And here is that entire top-to-bottom flow visually. Application, to SQL, to MariaDB, down to the file system, through CSI, into Ceph, and finally hitting the physical hardware. The huge takeaway here is the absolute separation of concerns. CSI isn't analyzing your SQL queries. It doesn't know or care what an insert command is. Its one and only job is just making sure MariaDB has a reliable, persistent bucket to drop its files into. Section 4, surviving a system crash. Okay, so everything works beautifully when the weather's nice. But what happens when things go wrong? Let's stress test this setup. Imagine your database is humming along on Node A, and then suddenly a catastrophic hardware failure. Node A just goes completely dark. Now, in the old days of traditional servers, you'd be in full-blown panic mode right now, but thanks to this architecture, an automatic rescue operation kicks in. Kubernetes spots the failure instantly and reschedules the MariaDB pod onto a healthy server, Node B. When that new pod spins up, Kubernetes spots the exact same persistent volume claim. The CSI driver jumps right back in, points to the existing volume, and mounts it to the new pod. MariaDB restarts, and your data, completely intact. It's an absolute lifesaver. But wait, what if the physical hard drive itself crashes? Like, literally catches fire? Well, if you're just using a single local disk, like you see on the left, your data is toast. It's a massive single point of failure. But contrast that with a distributed system like Ceph on the right. Ceph is smart. It creates multiple replicas of your data across different storage nodes. So even if one physical storage node is totally destroyed, your data is still sitting pretty on the others. The CSN driver simply reconnects to a surviving replica, and MariaDB doesn't even bat an eye. It's an incredibly resilient safety net. Finally, Section 5, the Enterprise Data Platform. Let's pull all of this together to see the really big picture here. If you look at this matrix, you can clearly see the separation of duties we've been talking about, and it totally busts the myth that Kubernetes is doing all the work. Kubernetes is just the manager, handling the scheduling and self-healing. CSI is your supply chain, getting the storage volumes created and mounted. MariaDB is the brain, executing the SQL and ensuring transaction consistency. And Ceph? Ceph is the vault, handling the actual data persistence, replication, and keeping things fault-tolerant. So, a true enterprise-grade data platform isn't just one magic piece of software. It's the harmony of these 4 distinct cooperating pillars. Each piece is doing exactly what it was built to do, and nothing else. And by separating these duties, we end up with an almost entirely unbreakable system. So, just to recap our mission for today, we learned that Kubernetes orchestrates, but it definitely doesn't store. We saw how CSI acts as that vital universal translator. We watched how persistent volumes allow our data to effortlessly survive a complete container crash. And finally, we saw how distributed storage, like Ceph, makes sure that even a physical hardware failure doesn't mean we lose our data. But all of this brings up a really fascinating final question. If Kubernetes and CSI have completely mastered the basics of keeping storage alive, how do we automate the rest of it? I mean, how do we handle things like automated clustering, failovers, and backups without any human intervention? How does Kubernetes evolve from just managing containers to actually running an entire database platform on autopilot? Well, doing that requires a whole new level of intelligence, the database operator. And that is exactly what we are going to explore next time. Thanks so much for joining me on this explainer. Keep exploring, and I'll see you in the next one.